In this video, I want to look at the distance and midpoint formulas. And the distance formula is another great application of radicals. The distance formula will give you the distance between 2 points, 2 points on a line or a line segment or on a shape in a plane. It's actually a little bit more difficult than just counting. When points lie directly above or below each other or left to right, then you can sort of just count along the tick marks. But when they lie diagonally at all, it doesn't quite work the same way. So we do have to use the distance formula here. So in this case, the distance formula D is given by the following. We have 2 points. We're calling them x1 and y1 and x2, y2. What you do is you subtract the x values, square it. Subtract the y values, square it. Add those two values together, and then take the root. So let's go ahead and try an example here. So I have the 2 points, 2, -5, and 1, -4. It doesn't matter which point you call 1 or 2. I like to label things. I just find it easier. So we'll call the first point 1 and 2. The first point 1 and the second point 2, excuse me. And then we're going to go ahead and plug it into that formula. So here I'm subtracting the x values. So x2 is 1 minus x1 is 2. Then I'm going to add that and subtract the y values. So y2 is -4 minus y1 is -5. You do want to be careful because the formula does have minus signs in it, so watch out for those negatives. One minus 2 is -1. Here my negatives will cancel. -4 plus 5 is 1. -1 squared is 1, +1 squared is also 1, and I have here the square root of 2 as my final result. Now, if I could simplify that more than I would, right, if I can break down that radical, or if you need to use your calculator, you could get a decimal approximation. A lot of our distances do come out pretty messy. It's not unusual. So just to give a quick sketch here of what we're looking at, again, this is not to scale, but so here's 1, 2, -1, 2, 3, 4. Let me go down a little bit more. We'll call this 5. So let's see. So this is 2, -5. And then I have 1, -4, right? So you have this little line segment here. So the length of this is equal to that distance, which is √2. So we actually use the distance formula for a lot of application questions that ask about length of things, particularly if we're looking at shapes in a plane. So that's a pretty common application here. But when you're getting that distance between 2 points, you're really getting the length of that line segment. So that's the length of the segment that's created between those 2 points. Another really important formula as well is the midpoint formula. So if you would like to know the halfway point, basically, of that line segment created by 2 points, then we do the following. We basically average the x values and average the y values. So let's do the same exact pair of points here. Again, I'm going to call this first pair x1, y1, and x2, y2. So then my midpoint would be x1, 2, plus x2, 1, all over 2. Y1, -5, plus y2, -4, all over 2. 2 plus 1 is 3. And then here I have -9 over 2. Or if you prefer the decimal form, I would have 1.5, comma, -4.5. Now, if I go back to my picture on the first page quickly, and try to graph this. All right, on the previous page, let's remember 1.5, -4.5. You would see that you get the point about right here. So 1.5, -4.5, and it's right there. So what happens is that midpoint really is the half. Move this up a little bit. The halfway point on that segment. So it is, again, really helpful. We do a lot of applications with this. This actually comes in handy as well with circles. Sometimes we want help finding a radius or a center or things like that. And actually the midpoint And the distance formulas really come in a lot as well with circles, with radii and diameter and centers and things like that. So there's a lot of applications that we do with these formulas.